Geometric sequence is a SOL that goes along with Chapter 8. It's kind of similar to what we did with arithmetic sequences, but you'll see the differences as soon as we get started. Be sure to print out these PowerPoints and make sure you're taking notes. It's a very short PowerPoint, so it shouldn't take you very long. Once you've got that together, we can begin. Before we get started, we need to go over some basic terminology regarding geometric sequences. A geometric sequence is found by multiplying a term in the sequence by a fixed number to find the next term. The common ratio is the fixed number you're multiplying by. Okay, so we've got a couple of examples of how to find the common ratio. Remember, that's the number you're multiplying by to get from one term in the sequence to the next term in the sequence. So we need to be thinking, how am I getting from 2 to 10? Well, because this is a ratio, you have to be multiplying. So 2 times what gives you 10? 2 times 5. Well, if 5 is our common ratio, it would have to work for every number in the sequence. So 5 times 10 gives us 50, and 50 times 5 gives us 250. So our common ratio for the first example is 5. In our second example, we're trying to see, how did we get from 3 to 12? Well, 3 times what gives you 12? 3 times 4 gives you 12. If 4 is our common ratio, we have to multiply by 4 to get to the next term in the sequence as well. 12 times 4 gives you 48. 48 times 4 gives you 192. In our third example, we're trying to figure out what number are we multiplying to get from 80 to 20. Well, you're probably looking at this and noticing that we went from a larger number to a smaller number. And more than likely your mind went to, we need to divide. However, remember that finding a common ratio, you have to find a number that you are multiplying by. But just like in arithmetic sequence, we can add by a negative number. We can also multiply by a fraction. So the easiest way for you to find the number that you multiply by is to work backwards. And the easiest way to do this would be to take the second number in the sequence and divide it by your first. So say 20 divided by 80, which reduces to 1/4. So if you say 80 times 1/4, you would get 20. 20 times 1/4 gives you 5, and 5 times 1/4 gives you 5/4. In our last example, again, we are trying to figure out, how do we get from 30 to -10? First clue should be that your first number is larger than the second number, so we're going to be working backwards here. Well, what is -10 divided by 30? That equals -1/3. So the number that we're multiplying by is -1/3. To get from -10 to +10/3, you're also multiplying by -1/3. From 10/3 to -10/9, you're again multiplying by -1/3. Our next few examples want you to find the next term in the geometric sequence. Before we can find the next terms in the sequence, we have to find the common ratio. Well, how did we get from 2 to negative 6. You multiplied by negative 3. So negative 3 is the common ratio. So to get from negative 54 to the next term in the sequence, you also have to multiply by negative 3. Negative 54 times negative 3 is positive 162. 162 times negative 3 is negative 486. And then negative 486 times negative 3 is positive 1,458. Just like in the first example, before we can find the next terms in the geometric sequence, we have to find the common ratio. To get from 1.1 to 2.2, divide it again. So 2.2 over 1.1 equals 2. So 2 is your common ratio. And then that has to be the same throughout. So what's 8.8 times 2? 17.6. 17.6 times 2 is 35.2. And 35.2 times 2 is 70.4. Just like in arithmetic sequence, geometric sequence is going to have a formula to help you find missing terms or specific terms within a sequence. Again, our A stands for the first term in the geometric sequence. R stands for the common ratio, and N is the number in the sequence that you're looking for. Okay, so just keep that in mind as we go through the next couple of slides. Okay, so now that we've talked about how to use the formula for geometric sequence, we're actually going to find the first, fifth, and 10th terms of the sequence A of n equals 2 times n raised to the n minus 1 power. Well, as you remember from the slide before, n represents the number that you're looking for. So if we're looking for the first term in our sequence, you would have A of 1 equals 2 times 2 raised to the 1 minus 1 power. Well, 1 minus 1 is 0. So you would have A of 1 equals anything to the 0 power equals 1. So that would be 2 times 1. So A of 1 equals 2. Anytime you're looking for the first term in the sequence, you can also remember that this first number here represents the first number. So that 2 was already there for us. Then we're also looking for our fifth number in the sequence. So you have A of 5 equals 2 times 2 raised to the 5 minus 1 power. Now keep in mind, when you put this in your calculator, you're actually going to do this math. So you're going to put 2 times 2 to the 4th power in your calculator. When you do that, you get that A of 5 equals 32. We're also looking for the 10th term in the sequence. So A of 10 equals 2 times 2 raised to the 10 minus 1 power. When you type that in the calculator, you would say 2 times 2 raised to the 9th power, and you get that a of 10 equals 1,024. We'll do one more example of finding specific terms within a geometric sequence. Again, we're looking for the first, fifth, and 10th term of the sequence. The first term, as mentioned before, is always this first number. So a of 1 equals 5. We don't even need to do that math. But we do need to do the fifth term in the sequence. So a of 5 equals 5 times negative 2 raised to the 5 minus 1 power. And you would get that a of 5 equals 80. And if we're looking for the 10th term in the sequence, you have a of 10 equals 5 times negative 2 raised to the 10 minus 1 power. Plug it in your calculator. You get that a of 10 equals a negative 2,560. Okay, we do have a negative number here that we are multiplying by for our common ratio. So it's important to note that every other term in the sequence will be positive, and every other term in the sequence will be negative. So you'll have a positive, then a negative, a positive, then a negative. On our last 3 examples, we just want you to identify the difference between arithmetic or geometric sequence. Remember that in arithmetic sequence, you're adding, and in geometric sequence, you're multiplying. So just keep that in mind. So, our first example, how are we getting from 2 to 4? We're adding 2. From 4 to 6, add 2. From 6 to 8, we're adding 2. Therefore, our first example is arithmetic sequence. Our second example, how do we get from 2 to 4? Well, if you look at your example before this, we could either add 2 or we could multiply by 2. To get from 4 to 8, the only way to do that is to multiply by 2. So our pattern here is going to be multiplying by 2. 8 times 2 gives us 16. Okay? So because we are multiplying, we have a common ratio, making this a geometric sequence. And then getting from 1 to 3, we're adding 2. 3 to 5, also adding 2. 5 to 7, adding 2. We're adding, therefore we have a common difference, making the last example an arithmetic sequence.